Dante Certification Level 2, Second Edition. Redundant Networks. You'll remember that in the Level 1 class, we talked about different network topologies. We certainly talked about daisy chain, and we showed a star network, but we didn't really get into redundant networks at that time. We saved it for this class. The idea behind the redundant network is that we can run two independent networks. The Dante device's primary ports can go to one network, and its secondary ports can go to the separate network. Now, let's suppose someone drags some scenery across a primary cable and cuts it. The secondary network can still get the signal from the mic preamp to the mixer. Then, let's suppose somebody else drives a Zamboni across some of the cables for the secondary network. Well, the primary network can still carry the signal from the mixer to the amps. So both networks are running all the time. So long as you can make a connection across one or the other, then the signal gets through unaffected. Notice that the mixer still has connections on both networks, so it can speak to the mic preamp and the amplifiers. However, if you wanted to feed a signal from the mic preamp directly to the amplifier, say you wanted to use it as a digital snake, that connection could not be made at this time. Those two devices cannot see each other on the same network. Hopefully that's clear. Now, when you set up the two networks, they must be set up in their own subnets on totally isolated VLANs. If you set them to automatic IP addressing and there is no DHCP server, well, we know the primary will default to a 169.254 range using the link local protocol. The secondary port will use link local as well, with one change. It will use the 172.31 range. And again, this is because we need to ensure that the two networks end up in different subnets. The golden rule with redundant setups is to keep the two networks separate. The primary and secondary networks should never be connected together. The reason why is precision time protocol is running on both networks. And if you link them together, the two clock leaders can start to interfere with each other. Now, the most common way that people accidentally connect their systems together is they take a device, they connect it redundantly, but internally it's still set in daisy chain mode. So now your Dante device itself is acting as a switch, connecting your primary and secondary networks together. Now, if you only do that with one device, you'll start to notice clocking problems in your system. If you do that with multiple devices, now you have the potential for loops in your network, right? So then the question becomes, did you have spanning tree engaged? And if you did, then it's going to turn off links to some of your devices. And if you didn't, well, then you've got a broadcast storm. So pick your poison. So again, the key is to make sure that you keep these two networks completely isolated. One way to keep your sanity when you're commissioning a redundant setup is to start with one network at a time. Ordinarily, when we look in Dante Controller, we should see something like this. The primary addresses are listed in one column, and the secondary addresses are listed in the other. But if I disconnect the cables to my secondary network, or just simply turn off my secondary switches, we can see those devices will now show link down. When you see that, you know the device is properly set for redundant networks. If you see any devices that show NA, that means the device only has one Dante port. Either the device doesn't support redundant networks, or the device is set in daisy chain mode. So if you're commissioning a system with a redundant configuration and you've turned off your redundant network, you should be able to go down this list, and anytime you see NA in that secondary port, you should be able to verify that that is a device that only exists on the primary. Now, of course, we all know that we can take our computer with Dante Controller and connect to the primary network. But did you know you could also connect to the secondary network? Frankly, you can connect to one, the other, or both. Let's show you how to do that. Let's take a look at the network interface page. You can get here from the File menu and select Interfaces. If you're a tool ribbon sort of person, you can click on the network icon here to get to the same screen. Or, in the bottom left, you can simply click on the P and S status buttons here in the bottom. By the way, the color of these boxes will indicate whether your computer is connected to the primary or secondary networks. However you get to this screen, Dante Controller will ask what Ethernet port you would like to use for Dante Controller. You can choose the network port for each connection. In this case, you can see I'm using my device on the primary network, but I could move my connection to the secondary network. Now, of course, these settings will not take effect until you click OK. If I have two network interfaces on my computer and I wanted Dante controller to be running fully redundant, I can set that up as well. While we're here, you'll see this little checkbox asking if we're using a shared Dante interface. This is asking whether there is other Dante software running on your computer, like Dante Virtual Sound Card or Dante Via. My computer is not currently running a virtual sound card, so I have this unchecked. So finally, we often get a question about whether we can use a common switch for both primary and secondary networks. Just split them on different VLANs. Yes, that will work, but that will create a common failure point in the design, right? If the power was to go out, it would take down that switch with your primary and secondary VLANs on it. Now, of course, this conversation can go on forever. You say, oh, okay, I've got separate switches. Did you plug them into different outlets? Or different breakers? Or different backup power supplies? Did you run the cables on different paths, right? This conversation can go on forever. Eventually, you simply have to decide how much uptime do you want. Now, in the IT space, they actually have a pretty good phrase for this. How many nines do you want? What they're asking you is, do you want 99.9% uptime, 99.99, 99.999, and so on? Each additional 9 typically offers logarithmically less benefit, but comes with logarithmically increasing cost. Now typically, the target is somewhere around 5 or 6 nines of uptime. And just to put that in perspective, 5 nines of uptime means you have about 5 minutes of downtime annually. 6 nines means you have about 30 seconds of downtime annually. And this goes to just how reliable networks are. This amount of time probably doesn't represent a failure as much as it represents your scheduled maintenance. In a final thought on this, it isn't unusual to design different sections of your system with different amounts of redundancy. Let's suppose we have a main performance area and we want to run that with full redundancy. Now, as you're designing this system, let's suppose you run into a budget crunch. Maybe something like a delay tower could be set on a single switch, putting the primary and secondary networks on separate VLANs. As you look at other parts of your system, maybe you decide that the lobbies and restrooms could go without redundancy. So, with that, let's do a summary. As we know, some Dante devices will support redundant networks for mission-critical systems. Both networks run full-time, so if you're putting the primary and secondary on the same switch, consider that in your bandwidth planning. The primary and secondary networks must never be connected together. They can be on separate switches or at least on separate VLANs. The two networks must also use different IP subnets. The most common problem people have when setting up a redundant network is that they accidentally leave a device in daisy chain mode when they connect it redundantly. A best practice is to start by connecting one network at a time and verifying that all of your devices are set properly. Of course, when you're setting up a system, Dante controller can be used on the primary network, secondary network, or for mission-critical events, both.